In the last class, we learned about breadth search or level order search, and we did this nice trick of passing it the height, using which we will print the height. We will print the node only when it is at level 0, and then we given a BFS, like given a tree, we printed the nodes in BFS 1, 2, 3, 4, 5, 6, 7. Literally, we printed 1, 2, 3, 4, 5, 6, 7 in that order next to each other. So now the next level of BFS is a very interesting question. It gets interesting because now I want you to print 1 and then 2 and 3 in the next line. And in the next line, you should print 4, 5, and 6, 4, 5, 6, 7. Or in other words, you are literally printing level by level in the screen. So you can separate them by a new line, separate them by star, star, whatever you do. But this actually is an interesting problem. So think about it while I switch to my iPad. Only host can share. You know what? Let's start a new iPad and all right. So let's call BF. You can see my screen, right? BFS underscore level order new line. Okay. So this is lecture whatever April 3rd, 2024. So now I go back to my own writing pad, open that. So that is there. So let me try. Got it. So I'm sharing my screen of my iPad on the laptop. So if I don't scroll down, remind me. So what we were doing was we had a tree like this: 3, 4, 5, 6, 7. And let's just recollect how we were printing it using iteratively. So let's say public. Okay. Public static void print nodes. Let's call it print nodes level order. And we take input node root. Okay, so now our goal is you can now even like start writing it in Python itself, doesn't matter. So let's say def print nodes level order. So what we were doing was when we started, we said, okay, let's start a queue. Let's put some value into the queue, queue dot append. We are pushing this first node itself root there. Then we start a new while loop. And the while loop is coming and asking again. See, this is to be small. This has to be small. Okay. Tell me if you cannot see. Okay. So while loop and while loop, we were doing while len of, and I switch colors. I have no idea why. Len of q greater than 1. First thing we do is pop the q dot pop of 0. We call that out and we print
Greater than
its
equal
value.
to 1, right?
Sorry, it should be 0. Let's call it 0. So now what we do is we print out dot value because val value, whatever val, let's define val L, and then we check if out dot left is not none. We just push it into the q dot append out dot left. Same thing if out dot left, out dot right is dot right is not none. Q dot append out dot right. Okay. So we are done. That's all we need, right? At the end of the day, all we have to do is go through each of these guys separately, keep pushing and popping, and we will exit when the queue is empty. So in other words, your queue will initially look like this, that if you go back to our same old tree, 1, 2, 3, 4, 5, 6, 7. So we first push 1. That is what we did before the while loop. We pushed 1. So at the starting of the while loop, we pop this guy out, and then we check if it has left child and right child, and we fill them up, right? And then we pop 2, then we add 2's children 4 and 5. Then we pop 3, we add 3's children 6 and 7. So on, your answer or your printed value is simply 1, 2, 3, 4, 5, 6, 7. But now the goal is, I want you to print like this: 1, new line, 2, 3, new line, 4, 5, 6, 7. This might look very simple at the beginning. So let's say even you can put star or new line or whatever you want, any demarcation or delimiter in between. But this is a very little tricky if you think about it. Not crazy, but because remember, we are kind of assuming that everything is coming one after the other. There is no way we are actually separating these things. How do you think we can do that?
First guess would be after the while loop, we have a print statement that will just print a blank line.
Okay, 1 second. Print each level in separate lines. Okay. So let's even, so you are saying after the while statement, put a /n, no? Print /n this way. Is that what you said?
Yes.
Okay, so let's try this out live itself. Donde estás me? All right, so let's go to, I thought I had it open, apparently not. onlinegdb.com. So let's, right, I think I even have one ready with, yes, perfect. So I have a class, I have a tree ready. So I'm just going to def, what is it called? BFS print, node root. Same thing we are doing. So we will just do q is equal to empty, q dot append root, while len of q greater than 0, q dot pop of 0, 0 is out equals q dot pop of 0. So let's say, we should look like, make it good tree, same as 1, 2, 3, 4. But anyway, if print out dot val, is it called val? Okay, so if out dot left is not none, you can see this, right? The one I'm typing code in.
Yes.
Q dot append out dot left if right is not none, Q dot append out dot right. Okay, and while ends, and let's run this, just plain this with before we add your idea. Let's see, root equals to create underscore tree, create underscore tree. We should even make it look exactly the same tree we discussed. Node, first nodes, left to child is 2 and 3, 2 and 3, node dot root dot left dot left is equal to node of 4, root of left dot right is equal to node of 5, root of right dot left, that is 3 children are 6 and 7. 6, left is 7, and this is 7. Okay, so there should be 1, 2, 3, 4, 5, 6, 7 in each level. So let's try, okay, BFS of underscore print of, oh, let's see what happens. Test node. Oh, left BFS of print node. Oh shit, Java. Welcome to Java. All right, so it prints 1, 2, 3, 4, 5, 6, 7, one after the other. Okay, so your idea was, let's go put a print slash n here. Okay, nothing happened. It printed a slash n outside the while. Did you mean inside the while?
Yes.
Okay, let's try it inside the while. Yeah, so now it's putting a slash n between everything. But remember,
Okay.
our goal is we want this to be slash, how do you say this? Anyway, the goal is 1, 2, 3, 4, 5, sorry, 4, 5, 6, 7 in every new line.
Okay. Okay. So I have another guess.
Yeah, this is the
So
whole point of the class. Now you come up with ideas, we'll try it out.
yeah. So basically we will have we will create a list of list where basically we'll create an output list, and to that we will keep appending the level nodes. Like one will be one list, two, three will be another list, four, five, six, seven will be another list. So these three lists will be part of an output list. So let's create an output list on top of the while loop.
Okay, I get it. So what you're saying is let's keep Q as the outer list, and I'm going to call an inner list.
No,
And inner list,
queue is the stack, right? We'll not mess up with the stack. We will
I'm not
have
touching it. I'm
another.
creating a new list.
Okay. Yeah. So
This is what you mean, right? Inside the while loop, you create a new list.
yes, and we have a for loop inside the while loop, which will
Mhm.
iterate. Basically, we are trying to get we are trying to append elements which belong to one level. And so in order to do that, we will have a for loop which will run until the length of the queue currently. So in the first time, the length will be only one. So this for loop will run once and append the add the output. Yeah, something like this. And we do everything which is, we'll put all of the code below inside the for loop.
So here, first time you come in, you want it to append out.val, right?
No. So first time when it comes inside, uh, all the code from line number 35 to 42, let's indent it more inwards. Like, let's move it in the for loop. Okay, and then after popping that element out, we will append it. I mean, out is not really accessible in line number 33. So yeah,
Sure.
after that, and before exiting from the for loop, we will append um, queue in, not in queue, no. So I think we will mess up with the queue. So let's have another output, queue out, outside the while loop. Yeah, empty list, and we will append in queue out. And in line number 34 also, that is correct, okay. And after the while loop,
Mhm.
outside of it, let's just print for level in queue out, print level. Basically, iterate over queue out and print every list. Yeah, in queue out, print level.
This way?
Yes.
Okay. Now let's try running that guy.
Okay, what is the in range?
Acha, no. Okay. 1, 2, 3, 2, 3, 4, 5, 6, 7. All right, we're getting there.
No, outside the for loop. The queue out dot append queue in. Line number 43, one indent towards the left. Yeah.
Ta-da.
Yeah.
Awesome. Beautiful. Brilliant. I didn't think of it. I had a completely different solution in mind, but doesn't
Can
matter
we
as long as.
discuss your idea?
Yeah. So my idea was very simple. Okay, so let me just save this also. This is nice. Control A, create new project. Save.
It would also be a good idea if you can add the code on GitHub.
Oh, all of these stuff now. Maybe I can even share this directly with you, and then okay. BFS one line per level. No, something like that. Okay. Okay. So my idea was going back here. So what is this? Okay. No, something else. What is this? So sharing. I want to go find the thing which had the Miro in it. So this one. All right. This is today's lecture, right? Okay, so I was thinking now that we already have this thing called Q, like don't do crazy stuff. So currently we are just adding 1, 2, 3, 4, 5, 6, and 7, right? And our problem was there was no demarcation between each line. So I was thinking, why not add a symbol in between this? No. Okay. So the only difference in my code was every time you add, so let me actually code this up itself. So now who's that now? Okay, this is not in full screen. This is in full screen. Okay, so let's go to the same projects. My temp is Atelier. So we are going to use same thing, create node, create tree. So this is our original one which we wrote. So my thought was, see, every time I append something, I will also append q dot append something, some sign. Okay, I just happen to call it dollar, right? So when you pop out, I just check if type of out is equal to node. Okay, I don't do anything. I do all this drama. I got pop dot and pop dot and etc. Else if out equals to dollar. So then I know that is when I'm hitting the endpoint. So every time I finish with the level, right, after adding both my children, I add a new dollar. And every time I encounter a dollar, I just print slash in, right? Or whatever, print
Slash n will work.
huh?
Slash n will work.
Yeah, slash n, but I was trying to make it more fancy with lights and fans and bulbs and all that stuff. Okay, so that's all I'm doing. So let me think about this once. When we come in with 1, we add 1 and a dollar to it. Okay, is the length of q greater than 0? Yes, we pop out 1, so we know it's 1. 1 comes out. 1's left is not none, so we have 2. You append 2, you append 3, and then you do q dot append dollar, right? And then you keep going, you're not getting into the else. So you come back, now you pop this next thing out, which is a dollar. So you saw a dollar, you put in slash n. Now you pop a next thing out, it is 1, 2, etc., etc. And run should work. Nope. Sorry, what am I missing? If type of out equals to node.
You're not printing the non-level.
Yeah, sorry. I don't know how I'm gonna get to that meeting in person, but that is okay. Okay, where are we? We are popping, and we should just print everything we pop, right? Print dot val. Is that correct?
Mm,
That's where it should print
Yeah,
on pop.
looks like.
Pop. Neither. It should be printed only if it's a node.
Okay.
Because I pop out one, and I don't want to print the dollar. I pop out one, and I print the dollar only in the end. Okay, 1, 2, 3, 4, 5. Wait, 4, 5, 6, 7 should be on the same line. So I don't know what happened there. 4, 5, 6, 7 should be on the same line. Okay, anyway, let me, okay, when this happens, we always go back to our whiteboard. So what I'm saying is, first time I hit, so my out, first time when you pop, it's 1.
It can be a good homework. I can figure it out.
It's no homework though. Wait, I have very interesting thing for your homework. So first one,
No, it's
was
just that
okay.
you have meetings, so I thought maybe this can be a good homework.
That's okay. That's okay. I'm saying I already solved this. Might have to look at the answer. BFS one line will print 24 10 baseless initial. Okay, this one. What did I do? Pen dollar. How does it print slash in? What does it? Yeah, Botanica has a print card, right? This thing. Anyway, so my only thought was if we can have some sort of a trigger which will tell us the end of this, it might just work, right? Because next time you add trigger 5, 6, and every time you hit dollar, you put a new line, and then you keep going, pop this, you hit another dollar, you put another new line, keep going, and theoretically you will be done with this when you print 5 and 6. So this is the easy part of the question, okay? So now you tell me in what is the time and space complexity of what we are doing. So let me even write it this way, right? So time, space, DFS, BFS. Okay. What is the time complexity of DFS when we were doing recursively? Okay, let's start with BFS itself. What is the time complexity for BFS? It's iteratively, no?
The number of nodes, like in the
Correct.
tree.
So BFS is order of n. DFS also is in theory order of n, but what happens is it takes slightly more because if you look at our DFS timing is 3507, apparently not. Anyway, but memory-wise, DFS will be a disaster because you have stack frames after stack frames after stack frames, right? Here, all we are using is a queue, and the queue is also having an order of n, okay? This also is order of n, but it'll be more than that because the number of stack frames is higher. My next question then is, can you do all this without an external data structure? So in fact, if that problem is not complex enough, I will give you the same problem this way. 1, 2, 3, 4, 5, 6, 7. And the new problem is, given a binary tree, connect nodes at each level, right? So by the time you give me the binary tree back, it should be like 2 has 3 things: left child, right child, and the next node. 4's next node is 5, 5's next node is 6. Okay, and plus without using any data structure. Do you have an idea how to do that?
Connect the node. So can we modify the structure node?
Yeah, you can do whatever you want. Yes.
Yeah, probably we can have another pointer in the class node that says my right, not my neighbor. So for example, one's neighbor will be null, two's neighbor will be three, three's neighbor will be none. Four's neighbor is five, five neighbor is six. So we have another pointer basically in the node class. Now, how to assign values to it, that is something I need to think about. But do you
No, you're
think
saying
this is right? We might have to
next. This
modify
is what you're
this.
saying, right?
Yeah, this is
Node
something.
class.
Yeah.
Yes, this is definitely right. But this is a very interesting type of problems because you need to keep track of two things. You need to keep track of your parent and your children at the same time. Okay.
Mm.
And this is the one I want you to think about. The reason is this shows up in a lot of these other problems, which is, have you heard of the champagne glass problem?
I know what a champagne glass is, but not a champagne glass
Okay,
problem.
so champagne glass problem or wine glass problem, whatever they call it. Let's even go to lead code. Lead code, champagne tower, champagne glass, whatever it is called.
No, I've never done this.
Yeah, okay. Now do this, but all I'm saying is all these problems have a bunch of same underlying concepts. Okay. So this is the question is, here's the bunch of champagne glass. Everything has size of 1 liter. So you pour 3 liter, of which one will be here. The rest of the two will be broken down into this and this. So this guy will have another one, this guy will have another one, so on and so forth, right? So the question is stack glass in a pyramid. Second row, each glass holds 1 cup of champagne. Some guy is poured. When topmost glass is full, any equity will fall down. So what if they give you input of poured? It's a decent one. So you're supposed to return how full j. If you're given a I and j, you should tell us what is the final value of 0.5. Okay, so you don't, I'm just saying FYI, this is there. Don't solve it. But I would rather you think about this concept. Like, how do you talk to parent and child at the same time?
Mhm.
Because remember, if you are at 4, you cannot connect 5 and 6. Like if I say, let's say you are doing BFS, right? From 2, you reached 5. Your control is in 5, but you have no way to access 6. Right? Sure.
Right.
When we create it, I'm not going to fill up the next value. That is your job to fill the next value. है ना?
Right.
So in create tree here, when we created, we just did left dot right, left dot right. We'll do exactly same thing when we give you the tree. Maybe only difference is here we'll have self dot next is equal to none. Okay. Now it's your job to make that connection and return the tree so that if I want to do a BFS in the given tree, all I have to do is 1, 2's next, my child 2's next, 3, 3, 4's next, 5's next, 6's next, 7's next. See exactly what we did. And the solution is basically exactly what we did, but we are bringing in short, we are bringing in linked list. You see that, right? So
Mm.
when we were talking about linked list, every function we were passing, your function will be, hey, print linked list node head. In tree, we were saying print linked list node root. Okay, so now we are actually combining both and we are opening up your mind into a world to realize that these are all just different low hanging fruits. Once you're so comfortable with all that, you can pull and pluck all of them together. So I'm slowly building up this step by step. Okay, to think about it. So
So we can
let's
use additional data structure
we
like a
cannot.
linked list. You said
No,
we,
I mean, this is not, I'm saying the node is the node of a linked list now. And you are only allowed to say next of 2 is 3. So there is really no linked list, but in theory, you are using that concept like 5's next is 6, right? So
Okay.
no external data structure, but think about it. If we are at 5, how can we get a pointer to 6 without going
Yes,
all the
yes.
way back up and
Yeah,
3 and
that's a
come back?
very difficult task.
No, it's actually very easy. Just think about it and let's see where we
Okay.
go with it. Okay, I'll stop
Okay.
sharing. Stop sharing, stop recording.